Bismillahirrahmanirrahim. Welcome back. So we're going to learn how to plot things on a Smith chart now. And in order for me to do that, let's try to understand how does a Smith chart works and what are some of the things which are present on our Smith chart. I hope you can visibly see that. So this is how our Smith chart is. If you were to look at it, you can see these concentric circles like these, which are going like this. You have circles which are going like this. These are your imaginary circles. So these circles are your real circles. All right, and you can see the circles which are going like this, lines which are crossing it like this on your Smith chart. If you were to see this, the lines which are going like this, these are your XLs, which means your inductive reactances. And same thing on the other side. So this is your center line right here. This is your center line right here. And on the bottom, you have these lines which are going like this. They are going like this. These are your capacitive lines, XCs, which means your capacitive inductances. So, and on the right here, this is your center point. This is where your Smith chart starts. Whatever you're doing, you have to start from the center. So these lines, these round lines, you can see they are going like this. These round lines like this. These round lines, these are your real lines. And the lines which are shooting up like this, from that center, the top part, this is your XL. And these lines which are going like this, like this, like this, like this, these are your capacitive lines, XCs. You always start off, and there are also something else. Right here, as you can see, you will see angles which are going across this. So the first one right here, this is actually angle of your transmission coefficient. These are the angles which represent your transmission coefficient, means how much voltage is going in. Transmission coefficient. Angle of reflection coefficient is the next one. So this states angle of reflection coefficient. And then right here, the third one, the third concentric circle, it says wavelength towards the load. So if you want to find out your load impedance, you will use this. And right here it says wavelength towards the generator. It's moving in this direction. As you can see the arrow, it's moving across this direction. And wavelengths towards the generator is actually moving across this direction. So one last thing, these concentric circles which are going like this, these are your real circles. The lines which are going like this, and actually it says that these lines are actually continuing on the other side as well. These are your inductive, because inductive impedances or reactances are in plus J of X, while capacitive reactances, they are minus J of X. So, and you have a transmission angle, angle of reflection coefficient, wavelengths towards the load, wavelengths towards the generator, and there are a couple more things at the bottom as well. So if you were to look at it, this top line, it says SWR. So if you want to measure SWR, this is the top line that you need to look at it from that center. So if I were to draw a line from this center right here, so this should be exactly the same line. This should be crossing this center line right here. So this is your SWR right here, from 1 all the way up to infinity. And this is your SWR in dB, from 1 all the way up to 40 dB. Then you have return losses, which is starting from here, from infinity going all the way up to 0. Then you have reflection coefficient with respect to power, so which is right here at these are the values, and reflection coefficient with respect to E or I, which means voltage and current values. If you were to look at it, if you want to measure the attenuation, this is the values that you need to use. SW loss coefficient, reflection coefficient, transmission coefficient is right here. These are your transmission coefficient, and transmission coefficient with respect to voltages and current. You can also see on the bottom part of your Smith chart, it says capacitive reactance, because capacitive reactance are in terms of negative, and inductive reactance, it is in terms of positive. So this is just a basic idea regarding your Smith chart. And in next videos, we're going to learn how to actually navigate through your Smith chart and how do you actually plot the values. So I hope you like this small tutorial. If you have any questions, please leave it in a comment section, and please don't forget to like and subscribe to my channel.